Reduce the following to their lowest terms. So what this calls for us to do is to look for a common factor, which is a number or a term or a variable that can go into another number or a term or variable without leaving a remainder. So what I'm going to do is to expand this. So it becomes 2 times a all over 6. Now I need to look for a number that can go into 2 and into 6 without leaving a remainder. I know that 2 can do that. So 2 into 2 goes 1 time and 2 into 6 goes 3 times. Notice whatever I divided by at the top is the same number divided by in the denominator. So 2 would have been the highest common factor. So when I check it out, what is left is 1 times a, which is just a, and we have 3 in the denominator. So when I reduce 2a over 6, my answer becomes a over 3. Let's look at another example. We're going to look at AB divided by AC. What I would do is to spread it just like bread and butter, when you're spreading butter over the bread. So AB becomes A times B, and AC becomes A times C. So I just expanded it. Now I'm looking for what is common in the numerator and what is common in the denominator. So let's go. A is common at the top and A is also in the denominator. So the common factor would be A. So I'm going to reduce the numerator by A. A into A goes 1 time, and A into A in the denominator goes 1 time. So I'm left with 1 times B, which is just B, and 1 times C, which is just C. So when I reduce AB over AC, I end up with B over C. Let's look at another example. We're going to do 6xy divided by 9px. Okay? So I'm going to spread it like butter on bread. So 6xy becomes 6 times x times y. And 9px becomes 9 times p times x. Now this one gets a little tricky. We have to look for what is common in both the numerical factors and the variable factors. Let's start off with the numbers. What number can go into 6 and 9 without leaving a remainder? 3. 3 can go into 6 2 times, and 3 can go into 9 3 times. Great. Let's look to see what is common between the numerator and the denominator. Here's an x in the numerator, and here's an x in the denominator. So x into x goes 1 time, and x into x goes 1 time. Can I reduce anything else? Is there any other common factor in the numerator and the denominator? No. So we simply just multiply across. 2 times 1, that's 2, and 2 times y is 2y. So I have 2y in our numerator. Let's check the denominator. 3 times p, 3p, and 3p times 1 is just 3p. So when I reduce 6xy over 9px, I end up with 2y over 3p. Let's do one last example. We have 8a to the 3rd power, b to the 5th power, all over 20a to the fourth power b squared. So we're going to spread this all out. It looks complicated, but just follow the steps. So it's going to become 8 times how many a's now? This is the exponent, which tells us how many a's are being multiplied by itself. So I see 3 on top of that a, so I'm going to have a times a times a 3 times. How many b's should I have? This number tells us. So we're going to have 5 b's. 1, 2, 3, 4, 5. Great. And remember, that's our numerator. So we're going to check the denominator now. So this will become 20 times how many a's? 4. So that's a times a times a times a. And how many b's would we have? 2 times b times b. Now we're going to have to check for the common factors. Let's start with the numbers. What number can go into 8 and 20 without leaving a remainder? And choose the biggest one. 4. 4 into 8 goes 2 times. 4 into 20 goes 5 times. Awesome. Let's check the variables now. There's an a at the top and an a down here. Can I cancel some more a's? 1 a here, 1 a there. Look, 1 more a here, 1 more a there. So notice I'm canceling 1 in the numerator with 1 in the denominator. Can I cancel any b's? Look, 1 with 1, b with b. There's nothing left to cancel. So we can multiply across now. 2 times b times b times b. How many b's are these? 1, 2, 3. So that will become 2b to the 1, 2, third power. Let's look what's left in the denominator. We have this 5 times a. That's just 5a. And that's how you get it done. That's how you reduce algebraic fractions to their lowest terms or simplest terms.